So yeah, we have the third speaker. Actually, Igor was my master thesis supervisor, so we have quite close connection with him. I'm most excited for this talk actually because he has a lot of experience in this field. So please welcome him.
Thanks. Yeah.
I will remind you of that.
Okay, yeah, thanks. Thanks a lot for coming. I'm happy to be the guy staying like in between pizza and talk. Yeah, and yeah, so I don't have any license on my slides. Moreover, I stole some slides from other people, but I have mentions, right? I did generate some memes, so but you can take them for sure. So yeah, like I'm going to talk about the future. And I hate to be the guy to talk about the future in the midst of hype. So here's my disclaimer. Of course, opinions are my own, and it's more a reflective discussion. So it's actually like would be really cool if you engage and just comment and like just engage. Yeah. So and there's going to be some implications, future projections that I see kind of available from what I read on Twitter. And I think you'll gain much more value from this talk if you just go through the links that I put here and there. And yeah, happy to chat about future afterwards. So let's go. Who am I? I worked at NLP last 5 years. I did dialogue systems before LLMs. And I did text search and retrieval, and I even did some multimodal retrieval with a paper here some time ago. And before that, I did some recommendations. So like here and there. So I know some things, although not an expert for sure. So about LLMs now. I really like this tweet, because it's actually what I'm trying to think when I'm thinking about LLMs, that you can be both amazed by their perspective and what they already achieved, and you can be concerned about the implications, what's going to be Yudkowsky kind of style, and but not actually thinking about it's going to end tomorrow. So you can resist both hype and doom. Imagine you can do this. So first of all, LM, it's a thing, right? It's not just a hype that came from Silicon Valley. It's big, and it's powerful, and it's task agnostic, right? So you can just put some stuff there and it will put it. Obviously, it will be some misalignments, but it's still going to be pretty cool. It's huge context window. You can put a lot of stuff there. You'll receive some result, right? So never seen before quality, emerging capabilities. On the right, you see the plot from a paper that says, okay, from some parameter count, you will see some emerging stuff that can do word unscrambling, which is super cool, I guess. And you can do fine tuning, which is another great thing. And you can do fine tuning in different styles. Another thing for those who actually don't want to train their models, it's available via API, right? You just plug it in and it works. And prices drop every month. Actually, I need to redo some slides because of the OpenAI Dev Day, and I just deleted some because my projections were wrong. Yeah. And but another thing, LMs have limitations, and it's okay. It's hard to govern. It's hard to navigate. It's probably never going to be solved up to like 100%. They are not specialized, and it means that some models will behave much better at some tasks. Specialized models are usually better, and we're going to talk about this a bit later. So this context window that we've been talking about on the previous slide is kind of leaky. Some of the models, okay, tend to first part and this last part. We see hallucinations, we see jailbreaks, and no SLA on OpenAI, and data privacy issues here and there, and unclear maintenance costs. Who are we going to rewrite prompts? We want to train models, right? And usage-based pricing, we're not so used to that as developers, as like machine learning engineers or whatever the term is now. So, and yeah, in some tasks, as you see on the plot on the right, it's actually not working. So like if you scale, it doesn't scale that well. Just like usual slide, how we get there. Okay, first of all, handcrafted rules, then mapping from features. Remember this times, FEMs, logistic regression, all this cool stuff. Self-supervised deep learning up to GPT-3. We still have some mathematics around that. We design our loss functions. We do learn features, but we still have some thinking around here. And then other reinforcement learning formulations. This damn thing with the reinforcement learning actually found some usability, right? It's not just papers. We're going there probably. So there's going to be some loss functions. There's going to be learned by the algorithms. And I stole this slide, so stole it from here. But like we have this path. What are we using this crazy machine for? So there's probably the biggest data set on usage that is available. It's from Vicuna paper, and it's like 200,000 unique IP conversations about what people actually trying to do with the LLMs. Probably you don't see anything, but here's the snippet. So it's mostly conversation, summarization, and generation of various source like code and generation of content. But of course, there's more to come. LLM helps NVIDIA with chip design. I read a paper that they actually trained the model, which probably makes sense, right? Because usual NVIDIA engineer makes a lot of money, and if you help even with small things, him or her is going to be like useful investment. There is a math teaching assistant, so you don't need to actually come up with your own like little tasks for your students. You actually can do stuff. Actually, this is a really nice link. There's a whole workflow how a person from a postgraduate position organize his workflow around using ChatGPT. Highly recommended. And of course, AI risk assessment driven by AI, as our B2B friends going in full speed to AI field. So another thing. But did the task change, right? So we had this huge explosion, Cambrian explosion with this LLM. So like, did the task change about like how we think the world, right? So what do we do with them? So we currently still do the traditional discriminative, although not all of them are discriminative machine learning tasks. So it's like classification, name entity recognition and recommendations, summarization. So all the things that were available to us before, we just like did it worse or did a lot of time with setting up things before we actually can go to predictions. And I don't have this picture, but actually I'm like in fairly big machine learning community, and they still do this with like they start to do it with LLMs just because they don't care to train their own models. But now we have generative ML tasks that somehow are now useful, right? So not just content creation, but really good content creation. And the implication of that is going to be on a couple of slides, but it's a thing, right? So we need to now adjust our expectations of what we economically should think about content creation. Anything novel, like completely novel, probably the only thing I can think about is the agents, right? So something autonomous that's going to be working for you on finding your tickets on Booking and building and writing an email to your boss that you're not going to make it on the Monday, whatever meeting. So automatic chain execution, which is a dream for everyone who works in corporates. So like just automate your work up to 100% and live in the forest. So not yet there, as it seems, and might not be there for really important tasks. Here's the link to a professor from Stanford, I believe. He does planning, which is really hard mathematical optimization kind of thing. And he tried a lot of experiments around actually trying to make LLMs do kind of simple planning. It doesn't work, probably because by the same reasons that LLMs cannot reword the word or count, like tell whether the number of words are even or odd. It's because of the way they're trained and the decanization, blah, blah, blah. So like there are things that won't be solved, and we need to find the sweet spot that is going to be useful to use LLMs and not the simple models. And like still like trying to build some tension here. So regulation, right? So what we have here. So with public benchmarks, they are gone. So it's not working anymore. Nobody cares about anything basically written in academic papers, and all this data sets gets overfitted the next day. So human benchmarks are questionable. When we say that there's an exam for a lawyer, we actually expect the person to work as a lawyer afterwards and not just like pass all this stuff. So we cannot rely on those human benchmarks. How do we weight long outputs? We don't even know how to answer that question, right? So we just generate stuff with LLMs and we say, okay, this sounds good. And okay, probably I did play around with the model, right? They say, and you're gonna understand how it performs. So it's actually not that simple, probably. So we need new approaches. And when we don't know what to do, we always do one thing, right? We test production. So there is a like distribution of people who actually thinking about testing in production, and we should be on the right side, I guess. So we need to test in production. And what is the example of that? There is a nice paper by I think like real software engineers turned into researchers. They try to apply LLMs to solve real GitHub issues. And what they did there, they just give to LLM the issue description, and in case of the assisted experiment, they also gave the exact files to LLM to actually solve this issue, right? The results aren't that great, so it's like below 5% for every model. Maybe a ChatGPT Turbo will solve that, I doubt that, but it's still, we don't know whether the training data was contaminated. So we need to test in production. We need to test in real life. And this is probably going to be a huge area of research. But again, like with GitHub issues, it's relatively simple. You just also crawl automated tests. And this is exactly what they do with other things. I don't know, medical, it's kind of hard. Another note of caution. So the fact that we now switch to the paradigm that we form our model not just with the data that we saw, but also with the interaction with RLHF, the goddamn thing. So we now have to like account for the bias that is there because of the population of users. It's not just the way we collected the data and we actually can filter that. The way we like released our model and we train after that, so we cannot like account for all the factors here. So we need to be able to do naturalistic observation. Let's make AI companies publish their transparency reports, right? So not gonna happen. So we're only left with the last options. So like we need to create corpus of real world usage. How do we see how it's aligned with our values, how it's aligned with medical knowledge or whatever? Super hard, nobody gonna do this. So what are the like implication that I see from the previous slides, from the previous things that I presented to you? What is the implication that could arise when we move forward with our LLM usage? So there's a niche where LLMs are too smart, and that means that we do task distillations from them, right? So for some classical machine learning tasks, LLM can act as an annotation engine to cheaply collect the data, even annotated. So even when the domain is fixed, it doesn't change much, it would work. Most of the supervised models outperform at classical ML tasks. However, patterns should be relatively clearly defined. Otherwise, LLM will perform better. So this is the snippet from a paper, and you can see that like loved by everyone, Roberta model beats even GPT-4 on some of the tasks for a few shot and 0 shows setting. Here is the reported numbers for that one. Of course, it's not going to stay long because it's going to be overfitted the next day, but still, like for your probably like your own task, it still makes sense to apply a simple model first, right? So if you have the data, if it's possible, it's going to be less carbon output to the atmosphere and blah, blah, blah. So another implication, with more generated data, we get less good data. So we have LLMs who actually eat the data real quickly. Now they start to produce the data, the generation point that I mentioned a couple of slides before. So there's a thing that called mode collapse. If you have worked with GANs, you know what it is. It's never gonna like happen for generative model to not arrive in a mode collapse if they train on their own outputs, right? So they're shifting the distribution of outputs into several modes. Usually it's the most prominent ones, most frequent ones. And models, there's a paper link to that one. So they inherit that curse. So you and companies might want to protect your data for one more reason right now, because of that. And yeah, so there's a picture from this paper. So probable events get overestimated and probable gets underestimating, and due to the finite sampling and approximate fitting, you're just gonna poison the reality data soon in the future. And we need to like hold to our data to actually produce something meaningful. Don't know how it's gonna happen, but yeah, this is the implication. Then we have another implication. This is called human in the loop curse. So like sidestep, do we need machine learning when we do some task? It's a great question. Let's say we have a candidate task for machine learning because your product, or I don't know, your C-level came to you and said, okay, we need some machine learning AI, generative AI stuff in our portfolio. So we conducted research. We found that cost of errors, false positive, false negative, quality requirements, all this stuff. And here's the typical funnel that goes when you actually trying to understand whether you need machine learning here or not, right? If you're not just want to spend budgets, right? So can we solve this task without ML by paying humans, right? They're most likely gonna do the best job possible. If it's not really expensive, we should go there. No. So can we just get this guy Peter to to build some heuristics around that and give us a good enough solution? No. Okay, so we need to do machine learning. So can we just take the model from Hugging Face and use it as is, like on my computer, like running? No. So we need to train a model, and can actually software engineer do this? No. So like, can we even do without human verification? So it's like there is a whole bunch of steps missed, but we come to this question anyway. If we need to actually human verify the output of the model, it goes into another game of actually understanding whether we can even go to this task, because some of the tasks are actually so that hard to verify than just to do the job itself, right? And several studies demonstrate a productivity boost for knowledge workers in tasks with creative component, right? For inexperienced or not less skilled workers, it's like up to 40%. So it's huge. For more experienced, it's up to 10-15%. So it's still kind of cool, I'd say. So the caveats, there is a falling asleep at the wheel phenomenon that is already there, right? So we have ChatGPT, which is if you compare it to 10 years old, it's probably smarter in some cases, but it can reason not at that level yet. So people over rely on AI. So if you introduce a human factor in verification of the model, and human let the model pass with their prediction, you have another risk of actually not able to catch this just let it pass kind of thing. So we need to do another check on human, which is hard. And it's by this research, it seems that variability of solutions decrease with LLM usage. So they tend to collapse towards average. So people don't think, people just submit, and they think that it's good enough, which is also kind of a troubling thing to think about, right? So if we just been lazy and like okay with the current status quo, so some tasks may still be able to solvable with LLMs pretty good, but some of them will remain costly just because of the verification. Imagine form filling use case when a lawyer must verify the generated form alongside the original. You should find the sweet spot of actually verification times that lawyer does to actually verify this piece of content, right? So there's a pricing involved to that. And here's another task that we need to think when we operate with LLMs. And here's the plot from the paper. You can see the clear difference when you apply GPT and consultants with just consultants in control. So there's a huge difference. And with overview, this is the moment when they have like a workshop on how to use ChatGPT or how to do prompting. It helps even more. So like one of the last implications, I think it's the less probable one. So we have the usability change in interfaces with chats. One of the biggest use cases for LLMs, as we saw on the plots and as we witness right now with ChatGPT, is chatting, like chatting about your PDF, chatting about your database, chatting about anything you like. As always, nobody asked humans, right, about that. Who wants to chat with the model rather than with the person from tech support? Chat interface by itself, is flawed. And there's a link, which I highly recommend, beautiful website on why it's actually not going to work in the future as the main engine of conversation between some model and the person. Text inputs have no affordances. What does it mean? So we cannot understand what's implied because text inputs are so unreliable, let's say, because they can mean several things. And when we do the pile of context with prompts, it means that we provide some hints, and it's not going to work for every case. Even for chatting, it doesn't work all the time. And another thing that we see when we interact with chat interface, that responses we get are isolated. That means that, if you think about the time spent on modifying some piece of content with ChatGPT, it would require you to read every line it produces. It's not very efficient use of your time. So chat as itself, it's not a very efficient interface as a reader bottleneck, but we're going to see them more and more because of the bias we have with this kind of models. And we have another problem is this implementation evaluation loop, when we ask to do something and we in the same chat we ask to evaluate the solution, or we try to evaluate the solution. So the context gets lost a bit. And this means that good tools make it clear how they should be used, and it's not that clear for chat interface. Although for LLMs, it's probably the best and most useful interface that could be, right? So usually people want to talk about the humans when they actually lost the cart, right? Finally, so if we want to interact with LLMs, we should have a mental model of them. And for now, the language is the best abstraction for that we have, but it's leaky, right? So we cannot fully grasp all the different things in the universe by language. It could be that things that we can solve with LLMs with human language are low-hanging fruits, which is fine, because it still helps us. But due to the fact that it's leaky abstraction, it's not gonna like really solve all the problems in the world. Another thing that is prominent after we actually discovered ChatGPT by I think anyone here. So it's you tend to humanize it, and of course it's not, and everyone understands it's just a model. It's just a bunch of flawed or not flawed numbers. So actually just a big pile of numbers. But we rely on our intuition, even when we operate with a strictly business manner. We rely that's actually much more prominent in their capabilities. And that's why our mental capacity to process this information is overwhelmed. And we tend to fall asleep at the wheel. So just like putting it back, my philosophy hat. So thanks for your attention. That's it.
Questions?
Yeah.
Yeah, thanks a lot for the presentation. Yeah, the question is pretty open. Like, what do you take on open source compared to OpenAI and other open source?
Yeah, like to be honest, I don't think that anyone can get that kind of compute, and it's probably will get better for open source LLMs when we have this LoRa adapters anywhere, and but it's not going to be that good. So, and I read some guys that actually believe in open source in terms of the like, can we build this kind of foundational model that could be that good to ChatGPT? We know this, what is it, Open Assistant project. It is the huge data set that they collected. But I think it's just not possible. So it's just like, it's gonna, like open source LLMs gonna solve tasks for sure. And they're gonna bring money and they're gonna be that good. But like we are far away from the level that OpenAI have already. Yeah. Okay.
I'll be wait on pizza. You can still, if you want, sample for users for what use case.
No, I think it's pretty clear that nobody, like almost nobody. Yeah, sure.
So you mentioned the text is not the ideal interface for these models.
Yeah.
Do you have some idea of what they could evolve in the interface?
Yeah, it's a good question.
Diagram, I don't know, something weirder.
So I think like not just the text, like chat as itself. Text, it's just language. We like, even with humans, we have some troubles with language. And I think if you are talking about the chat, usually there's this link, and they actually there's a person who explains why you need to add additional guidance to a user when you operate with LLM. And when you operate with anything that is kind of human-like, you need to add guardrails around that. You need to add filters, tooltips, whatever. If we're talking about language, I think it's not just solvable. So we have like math for exact input-output kind of things, but probably you cannot teach that to a model based on data, right? So there are multiple attempts to formalize some computation, yet they're not been successful as LLMs. So anything that is based on data is internally probabilistical. That's why it's going to tend to some distribution points that are more likely to appear in the data, blah, blah, blah. So you cannot say that there is a good interface to that. It's just another thing to actually operate with. It's just not an interface question. It's just like a tool. So yeah, I think I was clear. Yeah. Yes.
I actually agree with most of your points except for this one, because I think we have tons of examples of like AI. And I think it's interesting because the people reviewing AI say that it's addictive, that they spend 15 hours a day chatting with models. So you can say that, yeah, it's not believable, yeah, it's bad chatting, it's just a model, it's support, and people are just desperate. They have no friends, no one talks to, that's why they have to play with AI. But I think in parts, it should be the fact that they are good at making chats. They are entertaining to people, and people are willing to believe that there's a person on the other side of the monitor. So I think there is some current examples to this argument that it's just data speaking through matrices and some stuff.
Yeah, for sure. Like there are use cases that there's going to be massive, right? With those kind of applications, for sure. That totally agree here. It's just, I think, as a chat, as an interface for solving the problem, it might be at some point too cumbersome to actually navigate between the thing you wanted to do from, or like you want this thing to do, or to want to evaluate, let's say. There's a good example from a company called Honeycomb. They did plug in ChatGPT for their workflow builder, and it's kind of the company doing like logs, I don't know, maintenance and analysis, and they just plugged in, and it sounded like a good idea to actually promote their workflow engine, how to extract or how to query this logs data with OpenAI. The fact that people gonna talk about non-suitable for work stuff in this kind of content was not clear to them, but it's clear for everyone now. This people gonna abuse this chat interface. So this was my point. But of course, if your product is like suitable for this niche, then for sure. Yeah.
I agree with your points, but I also one of the things that I just want to clarify that basically when you are actually doing when you are doing an inference, it's basically a probabilistic model, and it's sampling from the words. And it started, if you remember, it's a globe which basically Lang showed that it's basically a co-occurrence matrix, and now we are increasing the parameters, and we're hoping for sure. I mean, we know most of the human beings use maybe 10,000 words to communicate and over the internet, because there's Bill's law and all sorts of stuff. So I'm hoping it's not entirely can be a co-occurrence matrix, because, and the other part, we basically don't know what it is actually, and the most of the module basically, if you think that before GPT 3.5 and then the leap to GPT 4, the only change was basically reinforcement learning was one of them, but other things are just increasing the parameters without taking into account any of the other modalities. Because when we are learning a language, for sure, obviously we do exactly those things that prove the task that fill in the blanks sort of, or make sentence prediction. But also we correlate with other things like images or real-life models and stuff like that. And this thing is somehow, I can understand it's a difficult problem to formulate and also to evaluate even more. But this thing is not being observed too much, or it's not still a focus of the community. What do you think? Do you think this would be maybe a better approach towards solving the problem?
You mean like involving multiple modalities? Yeah, sure.
If possible, if we don't know how we learn, if we knew, obviously we could do something like that. So we don't know how we learn actually. So now, so what do you think on that? Do you think modality will be a first step, and then to put some logic into it, like, because otherwise it's just doing the same thing over and over again with multiple more parameters. We don't know what it's learning. So
yeah, I think like it's pretty clear that all the algorithms are super hungry for information, right? And even from my research from 2 years ago, from multimodal retrieval, it does work. So like adding multimodalities even for simple problems works better. So it's source of information. That's why you will need to find, like, as a person who learns how to speak, like little child, you show it to the nose and say, okay, this is the nose, and the person learns correlations, right? About speed of learning is definitely a thing, right? In the future, we would like to update the state of the model much faster than just like running another round of 6-month training on 10,000s of GPUs. But to your point about like building some representation, right, of the world, we already see that LLMs have some representation, even geographical one, from just inferring from text. There are papers who actually show that up to an extent the distances from the Earth I learned. So I think there is a path. I just don't know whether we should consider it human path. It's going to be some different stuff, and we definitely need to learn faster, learn to learn them faster, because it's crucial, and we get a lot more information as humans, and they just simply cannot process that efficiently for now, at least. Yeah.
Do you foresee anything beyond the transformers?
It's like there's I actually wanted to reference the bitter lesson of this essay of bitter lesson, and I think to this one as well. So like the weaker the bias and the more the compute, the better, right? And the transformer architecture is relatively like as a bias to, let's say, okay, there is a relation between stuff, and you can calculate some metrics of relations. It's relatively weak bias. I cannot imagine anything more weaker. Even like if you think about GPT training, like when you predict the next token, what could be like more like beginner weak than this formulation? I think like scaling in the end will beat it all. So it's just a question of GPUs, just a question. Maybe there's going to be some clever implementations of some stuff, but in the end, we all surrender to the scaling laws, and that's it. This is a bitter lesson, yeah. So I guess that's it. We have pizza, right? So thanks.